I was super excited because I was going to perform wake frequency calculations for the first time. Finally, the work was completed. I was happy because I had not just completed but double checked my work, and I was sure that I have checked every single parameter, the equations, and every single thing that goes into wake frequency calculations. The next day, when I came to office, I was scared because I realized that I had made a big blunder and that all my calculations were wrong. I was confused. My manager said that you have made a big blunder in your calculations. And I couldn't understand what could have gone wrong. I had checked all my calculations, all the process data, IPTS, equations, everything. But there was a big blessing in disguise. He said to me, "You have to figure it out on your own. I will not help you in this case." This seemed to be one of the best things that could happen. So I was wondering what could have gone wrong, and then I did what we usually do. I tried to double check everything. I tried to check again the process formulas, every single thing. But you know what? Everything was correct. And yet, how can the final output come wrong? This seemed to be very confusing. And finally, I was laughing at myself because I realized that I had made such a simple mistake that I was thinking for some complex issue or something which is very complex. But then I realized it was simple laws of physics that I had to focus on to. And then I realized that I had to focus more attention onto my 8th grade class. Else, this mistake would have not happened today. So I would love to share this part of how simple laws of physics can actually affect our engineering projects. So let's look into it. So let us look at three basic parameters, three simple parameters. The first one being the equation. Volumetric flow rate is equal to velocity into area. This is a simple equation. So we'll call the volumetric flow rate as Q. We'll call the velocity as V1 and the area as A1. A simple equation. We'll first look into the relationship between the area and velocity. So if you notice here, we have to maintain the flow rate constant as per the equation. So what would happen is if I decrease the area, which you would notice here, the volumetric flow has to still remain the same. So the velocity will increase. So area and velocity seem to be inversely proportional to each other. Now, how did this lead to the problem? Well, we'll discuss that. So, first I'll discuss the problem, and at the end of the video, I'll discuss the solution as to how we can avoid this once and for all the projects that we execute. But first, let us look into the problem part of it. So, here, this first case is where the Thermowell is over-designed. Maybe we are being too cautious, and the Thermowell is designed in such a way that we don't require that much amount of thickness of the thermowell or the length of the thermowell, but we still take something which is over designed. Let's look into that case first. This especially happens for smaller line sizes. Because for smaller line sizes we have to sway up the line size up to 4 inches, like example half-inch line size or 3/4 inch line size and so on. Here in this picture, if you notice, the velocity V1 is entering the pipe, but we have switched the pipe in such a way that the thermowell should be able to insert inside the pipe. So we have switched it, maybe for example an half-inch pipe is switched up to 4 inches. Do you notice there has been a change in area? So the velocity now here will not remain the same. The velocity which entered, which was V1, and at the thermowell would experience a velocity V2. And you would notice that the velocity V2 is far less than the velocity V1. So if we take the process data which says that the velocity of this pipe, the fluid in the pipe is V1, that is not correct. It has now changed. So maybe we design a thermowell which is too stringent with regards to the requirement of velocity, which in turn affects the wake frequency calculations that we do. Now, the most dangerous case of all. What if your thermowell is under designed? Underdesigned Thermowell is one of the most riskiest thing that can happen to a plant. You might maybe not trust that. But do you know a plant was shut down for 15 straight years? The Monjo fast breeder plant in Japan was shut because of a thermowell failure, because of the wake frequency calculations that was done there. And it led to the shutting down of plant for 15 straight years. So that means we should not understand that this is a small instrument and maybe would not require that much depth of understanding or that much consideration. So let's look into this case. Here what had happened was that this dangerous situation was caused because the opposite of our case 1 had happened. So let us assume that this is V1, the velocity which is entering the pipe, and the velocity V2 is what the thermowell would experience. Now, if you would notice that the thermowell is experiencing a velocity which is far higher than the entrant velocity V1. This is a very hazardous situation, and the thermowell failure in such cases is very common. And a thermowell failure can not only affect the instrument itself but can also harm the instrument's downside of the pipe. That is maybe a magnetic flow meter or turbine flow meter, or worst if there is a pump. So for such cases, this becomes a huge point of concern. So what is the solution for such an issue? There's an idea. One solution which maybe could help in such a situation is as follows. To use the idea of mentioning flow rate instead of the velocity. Why? Because we know that the flow rate is going to remain the same regardless of the velocity. So if the process gives us flow rate and we calculate the velocity, how? Because we already know the area, that what is the area of the pipe. So with that we can calculate the velocity ourselves as instrumentation engineers, and this can help us to avoid this error of which velocity is correct or is the process given as the correct velocity. So, in conclusion, we can say that we need to always confirm for the velocity, or the best solution would be to ask flow rate from process engineers. If that is not possible, or if you would not want to go with this solution, then the other solution is to always verify with the process in case if there's a switch up of the line or switch down of the line, whether the velocity given is considered with respect to the line size. I hope you found this video valuable.